We have a lot to cover here, actually. So we're going to have to talk about macOS techniques, new techniques, and as the name says here, we're going to talk about the cat chronicles, TCC bypasses, breaking sandboxes, getting cookies from the browser without user interaction. So there's a lot of stuff to cover here today. So just presenting myself, who am I actually? So I have 10 years plus of red team experience. I've tested a lot of environments, AD, on-prem, Azure, AWS, GCP, Linux. Currently, I'm testing a lot of macOS. So I hear a lot of people just saying, well, we don't see macOS a lot. So I hope that this presentation can actually give you guys a good idea about how macOS actually works. So I also have some community contributions. So I developed Dark Melcore, Harvest, which is a C2 automation framework. There are some Apollo updates for Mythic C2, Mythic DNS profile, Night Vision, which is a reconnaissance framework I created some years ago. I'm a big Mythic fan. I created DNS C2 and used that for quite a while, actually. I love Rust. So Rust is my language for MalDev. If you guys want to talk about Rust later on, just ping me. And I also play some Commander MTG. You know, if you guys play Magic, just let me know. Let's have a match. So yeah, let's get started. We're going to talk about today. We're going to talk about macOS, the red teaming landscape. So we're going to talk about some talks that we had before about macOS and how most of the things actually used to work before Sequoia update. We're going to talk about breaking Office macro sandboxes, which is a topic that people haven't talked about a lot in the past years. We're going to steal cookies from the browser without letting the user know. And we're going to have browser dominance. So we're going to control the browser completely. And then as a bonus, we're going to have a TCC bypass that's also going to generate some telemetry confusion to everyone that's actually analyzing. So for everyone that's getting started, there are two talks. They're pretty good on macOS. So we have the evolution of macOS, of Mac threat landscape from Thomas Reed, and Gone Apple Picking, Red Teaming macOS Environments from Cedric Owens. So these two talks are pretty good. They present how most of the things in macOS, they work, or actually used to work. So they get you a good impression about JAMF deploying, some tools that we commonly see in macOS environments like Okta, some evil jinx attacks, and also like how Gatekeeper works, some tricks around Gatekeeper for example, like right-clicking open to actually get past Gatekeeper, how XProtect work and how it blocks some of the things that you commonly see in macOS, how TCC works, right? So that, you know, for some of you guys that don't know a lot about like macOS, TCC is essentially the prompt that you get to, you know, authorize some application that's actually running. Some how sandboxes they work. So like containers, how the app that's running in Sandbox is limited, and so many other things. So these talks, they're really good. I highly recommend you guys to check how these work. But it also presents you guys some techniques, for example, like delivery of payloads. So for example, the PKG right-click install trick, which is pretty good. Some Office macros techniques, some previous exploits with regex, and many other things. So for example, like interesting file locations, lateral movements, persistence using the common trick of like launch agents and stuff, and even some CI/CD misconfigurations. So these two talks, they give you like a good impression about how the macOS environments work overall. But there's a little problem. So we had macOS Sequoia update, which kind of like broke a lot of stuff. So right now, we don't have the trick of right-click, enter anymore to bypass Gatekeeper. I mean, you can still do that, but the user will get an alert, and the user actually needs to open the configuration settings and then allow the application to run. So there's a lot of steps to do that. It's a pretty good update, actually, right? So there's a lot of steps for the user to do that and to allow the application to run, that at some point, if the user is actually allowing this, he really wants to actually run this, right? So that's the prompt that you get. So it gets a prompt just saying that a package cannot be run. That's just because it is not signed. So Apple just enforces the signature for everything that's running, right? So that's a pretty good protection. And now you have to actually open the configuration settings and then just allow the PKG or the unsigned application to run anyway. So there's a lot of steps, right? So if the user is suspicious, you will get more suspicious with all those steps there just required to actually run the application. So previously, we also had a lot of malware just approaching this differently. So you can see this DMG right here on the left, just actually requiring you to right-click open. That's a very good delivery mechanism. So it pretends to be Safari update and then just actually prompt you to right-click install. That's really, really interesting technique. But right now, we see attackers just doing something different. So attackers, they always find a way around the protections that you have. So for example, here for the solution install thing, what they do is they just require the user to open terminal and then just drag and drop the solution install, which is actually a bash script just disguised as an application with the fake icon. They just drag and drop that bash script into terminal. And we see that with many other applications. This is a common thing that attackers are doing. But now they're just quite trying, they don't have many ways to actually get around Gatekeeper. So currently, what we have publicly is this technique to drag and drop into terminal. So the goal of this talk is to find probably another way to get around this, right? Maybe using Office documents. So what about Office documents, right? So before 2019, what used to happen is that we used to have a lot of campaigns. We had this US Allies document, the Bitcoin magazine, and it used to be a lot easier, right? You just need to actually download your macro and execute. Sometimes you used to obfuscate and encrypt that, but there's no sandbox restrictions. So it used to be pretty easy. And then 2019, 2022, we had the macOS, the macros were actually sandboxed, right? So there was a pretty cool CVE that was mentioned in the MDSec blog. So this CVE just essentially found a bypass around the regex that kind of like limited what you could actually write and what not to the file system. And with $, there's a pretty cool bypass. And it's still adapting, right? So here's the Empire shell. So you can actually, if you added the tilde and the $, before the file name, you could actually just write to any location. So that's a pretty neat bypass. And what you can actually do with this, you could actually just write to the launch agent's location and then get persistence and command execution to the file system. And other things too. There's another CVE 2021 that abused environment variables. So what you could do is you could initialize the home environment variable, and before launching the open command to terminal would inherit these environment variables just set to the home, right? So you could actually just set a bash script to actually execute that. So it was pretty good, right? So now what happens, right? So Apple just limited that. All the environment variables are pre-initialized in the sandbox environment. So now home environment is just limited to the container location of your application. So most all of the environment variables are just like pre-initialized. So another one that's pretty interesting is abusing Python stdin. So this one, you would actually launch Python and then just specify the standard in location, and then you could actually just specify your Python script. One thing to notice about this one, when you launch an application using open, this application is not sandboxed. So this implies a lot of things, and it's the base for the technique they're gonna just present here today, right? So when we launch the application using open, if you're able to pass arguments to this application is not gonna be sandboxed. So how about Office documents in 2024? Well, we don't have anything yet, but every sandbox technique should still apply, right? So we kind of have some things, but not specific to Office. So let's break Office macro sandboxes right now. Okay, so let's take the open command as an inspiration, right? So everything, as I just mentioned, that you launch with open command is not going to be sandboxed. But what can I actually launch, right? So as you saw, Apple did a great job actually just fixing the environment variables and the arguments just used to launch applications, right? So how can I actually pass arguments to these applications? Also, another thing, file modifications is pretty restricted. So everything's quarantined. You're limited to your container location. So, well, can you use like something just like CV 2022 or say CV 2021? You know, passing arguments? Not actually. But there's another idea, right? So let's look back at the open command. If you try to pass arguments using the open command, most of the time it's just going to invoke this specific three functions: fork, execv, and POSIX-spawn. So all of these functions, they're just filter. They pass through the sandbox profile, and they're kind of like filter, and they check for the specific entitlement for the allow external execution. So if this specific entitlement is not set, what's going to happen is that your application is just going to be denied to spawn or execute anything specifically, right? And again, environment variables are just filtered and pre-initialized in the sandbox context. So what about schema handlers? So that's an interesting thing, right? So we have schema handlers for many applications. We have for Slack, we have for Zoom, VS Code. So if you're able to find an ODA or a way to actually launch an application to run specific commands, and you just pass that schema handler directly to the open command, that means that application is just going to be spawned without the sandbox profile. So that's a way to actually escape the sandbox. But you know, this one's mostly related to the application that is handling the initialization, right? So no application should have a specific way to run commands through schema handler by default. Some applications do, some applications don't. There are some CVEs, I cannot actually talk about these ones, but there are some CVEs in big applications that you can actually use nowadays. And but can you actually find an application that is installed by default on Mac that can actually use this trick? So I did a lot of research. I couldn't find one to do this, but I did find a pretty interesting schema handler that you can actually use to spawn the configurations of profiles on your Mac. So let's think about this for a moment, right? Can we just use Office sandboxes, or actually Office macros, to spawn the profile configuration page on your Mac settings so that the flow for the user to install the profile is a lot faster and less suspicious? Well, we can actually. So why not use mobile config profiles? So what are actually mobile config profiles? So these are profiles that set actually configurations for you on Mac. So you have many different configurations. You have Wi-Fi configurations for profiles, VPN settings. You can set up email, certificate installation. Well, not right now on Sequoia. We're going to talk about that later. You can restrict or allow applications. We could even set persistence through this and MDM join applications with this one. So that's really interesting, right? Can we actually do this? Well, we can. So we're going to use, the thing here is, let's use a mobile config profile, or actually let's just use the macro to launch the installation of a mobile config profile. And then let's have a mobile config profile that can do something in the machine, right? So VPN, well, that's good, but not in a, campaign specifically. Email settings, that's actually interesting, but we don't get like command execution or anything. MDM settings, that's pretty good, but if your device is already MDM joined, you cannot have two MDM profiles. So that's kind of a limitation. We're going to talk about that later. But there's an interesting one. You have this network proxy configuration profile. This one is really interesting. This means that we can actually just install a profile that proxies everything in the machine through your proxy, right? But there's a problem with this. So Firefox uses its own certificate chain, which means that even if you install a certificate to the keychain, Firefox is going to break. And we don't want the user to notice this, right? Otherwise, the campaign is just going to be blown, right? So what else can you do? Well, there's another profile. There's this global HTTP proxy. And this one allows a pretty interesting configuration, which is the proxy pack fallback allowed. So this configuration, it allows you to set a pack file remotely. Now, what's the advantage of this? Well, pack files just allow you to actually have different configurations for how your proxy work, right? You can filter some specific connections. You can redirect to specific proxies. You can filter based on IP. So there's a lot of things that you can actually do with pack files. But the most interesting thing is that you can set your pack file remotely. Now, why is that? Because when you set your proxy profile, all the applications, or most of the applications in your Mac, are just going to request this pack remotely. And each application is going to have a different user agent. So by having a different user agent, you can actually block any Firefox user agent requests to your pack file. So with this, you can just block Firefox and have the proxy pack fallback allowed. Now, when Firefox is not able to get the pack file, it's just going to fall back to not actually using proxy at all. Now, you lose the ability to proxy Firefox, but you can still proxy any Chrome-based application, any actually Chrome-based browser. So that's fine. It's not going to alert the user. It's not going to blow away your operation. So that's fine. And another thing that you could do, or actually used to be able to do in the past, it's add a certificate to your proxy profile. So now when the user installs the proxy configuration, it can also install the certificate, your custom CA, directly to your Mac, so your proxy is just going to work. Now, how is the actually macro designed, right? So you have multiple things. So all of the codes in this presentation, they're going to be on my GitHub profile. So if you guys just notice in the footer here of every PowerPoint presentation, every PowerPoint slide, all the codes are just going to be in my GitHub after the presentation. So what can you actually do here? So the first thing is, let's just monitor for a new IP, right? So usually when you target Word documents, we have a lure in the first page, then we just ask the user to do something, and then we just remove the front page, and then just present the document, the fake document, to the user. So what's the trick here? Well, first thing, we just monitor for a new IP, a new proxy connection. If you get a new proxy connection, we just remove the first page and show the content. Then we just, if we don't get that, let's just keep prompting the user to accept the installation of the profile. Download the profile, force open it, ask for install, and then just keep doing that until the user accepts. So let's have a look at how it works actually. So the user just accept opening with macros. Then you have the profile, just keep asking. So you can actually present a pretty cool message here for the user. So you can just customize this prompt here to keep asking for the user to actually, accept your installation. You run that, you get the profile downloaded, pop-up, you install the profile. Now your certificate is also going to be installed. And then everything is just going to be proxied. So right now, you get all the traffic from the user just proxied through your server. So now you get cookies, you get everything there. Now, there's a lot of steps that are required for the user using this, right? And there's another problem. Well, Apple just fixed this, right? So Apple just changed how certificates are installed on your machine. So now SSL certificates, any certificate actually, even if you use profiles to install it, they don't get the single trust setting that we actually need to do this. So we don't get the SSL trust setting for this. That's a big problem. It worked until 2024, and now even like some engineers are just complaining because they have servers to manage. They need to install this without user interaction, right? So a lot of people are actually complaining about this. But there's a solution, or a bypass. And again, just talking about MDM profiles, you can still use this technique to install MDM profiles, right? You can still do that, but the problem is, as I mentioned, MDM profiles, you cannot install another one if the device is already managed, right? So that's a big problem. But let's look at 2025. Is there anything that we can actually do? And yes, there's a much, much better technique that we can do. So let's look again at the Office documents entitlements, right? So if we look at the entitlements, we see this specific thing here, just protecting Office from writing to locations like library launch agents, right? And why is that? Well, Office, when you open a document on any location, when you write your document to any other location, it kind of gets like a temporary permission to write to that folder. So that's how Office works, right? Originally, when you open Office, it is limited to writing to the container location. But when you open like a folder or a file name or a different file, you get like temporary permission to write to that specific location. So keep that in mind. Now, what happens if we use our macro to try to open another location while Office is still running? You get this cool prompt here to actually grant access to Office temporarily. Now, that's weird, right? If I ever see that prompt, I'll get pretty suspicious about what my macro is actually doing, right? So now, what it can do, we can actually set our macro to do the Finder dialog, to prompt the user to accept and choose the open location of some other folder. So we can actually specify the /folder location, and there's just, get writing permissions to your host system, or almost your host system. So you can just keep prompting the user to accept this new location until he actually accepts that. And you can even customize the message that the user gets right here on top, right? So you can just say, well, Office or Word just failed to open your document. Please try again and click on choose. So you can just keep prompting the user until it accepts. And that's the only thing you need to do. But there's another thing here. So everything's quarantined. That's a big problem, right? So even if you get like writing permissions to any place, actually, you cannot write to launch agents. Everything's quarantined. So even if you get like a binary there, you don't have like the necessary entitlement to run that binary. And even if you had, that binary would also be sandboxed. But is there any other plist that we can abuse with this technique? And yes, there is. So there is this post from 2021, this very interesting post talking about terminal preferences persistence from this blog here, Beyond the Good Old Launch Agents. So this blog approaches a lot of persistence techniques. So I just thought, well, let's see if there's any persistence that uses a different plist other than like launch agents or launch daemons or anything like that. And there's this one, very interesting. So this one, you just open your terminal, you go to profiles, and then you set the command to run right after initialization of terminal. And then what happens is that it will just write your configurations to library preferences common Apple terminal plist. So now you have a plist, and this one is quarantined. But there's a thing, right? Even if the playlist is quarantined on Mac, the application that's using that playlist is still going to use that. So you don't have like limitations with playlist notarization, which is pretty good, right? So the trick is create your terminal profile, save that one, move to the other machine, or actually just have your macro download that, and then just replace your terminal playlist. And now that's it. You have your sandbox bypass. So let's see how it actually works, in practical terms. You can see here the terminal, it's already open. So this means that even if terminal is already running, it's gonna spawn a different one, right? So you don't have the problem of having the application already running there. So let's see how it works. Now here, the user just keeps like trying to select a different folder location, is not able to try to cancel, and then that's it. You get your shell. So a lot easier, right? Then you get your callback. Then you try to see the documents folder. Take a while. I'm sleeping for 10 seconds. So yeah, let's wait a bit. Okay, submitted. Send a message. And there is. So now that's the only thing you need to do, right? So you just keep prompting the user to accept the new location of your folder. And you don't need to specify the / location, right? You just need to specify the library path. It's fine, right? But as for convenience, I just specify the / location, right? So now the only thing that the user needs to do is accept the new choose location. And it's not going to be able to see the document until you actually accept that. And if it accepts it, you get your shell and also your persistence. Yeah, so now let's work with cookies, right? So now we have our proxy, our shell, but let's go back to the previous advantage that we had with proxy profiles, right? So with proxy profiles, we'd actually proxy all the traffic from your machine and get the cookies. But with this one, we get a shell and a persistence, but we still don't have the cookies. So let's think about this for a moment, right? Can we actually write certificates to the keychain directly? We used to, as I mentioned. So we used to be able to run this specific 2 commands that actually granted authorization to install certificates or actually modify trust settings, right? The admin authorization role. And you just actually needed to run this add trusted certificates to have your certificate added to the keychain directly, right? That's pretty easy, no prompts, so pretty fast. But now what happens is, well, Apple just fixed that one too. So now whenever you try to write or actually modify your trust settings for admin, you get SIP deny, right? So that's a big issue because a lot of developers, they just want to, you write your certificates without user interaction and then just add that to the keychain. So that's a big problem, right? So is there any bypass to this? So when I was testing this 2 weeks ago, Apple had fixed this. And I was like, man, come on. I got to find a way to actually present something new for you guys, right? So when I was testing this, I tried to add the certificate to the system keychain. And, it just got the no trust for all the attributes. So I just left the certificate there. And then I just try like, well, let's see if there's any other authorization. So I just noticed this trust settings user authorization, which is pretty similar to the other one. So this one just grants you authorization to write to the trust settings, but only for the user. So the system keychain, you're still blocked, okay? So yeah, that's good. Now, I just tried to actually add the certificate to a custom keychain. So I created a custom keychain, added the certificate with full trust to this custom keychain, and then added this keychain to the search list, okay? So now you can see here, the certificate is fully trusted on the new keychain. But then when I look back at the certificate that I had on system keychain, that one was also trusted for some reason, right? So now what happens is, let's recap. If you just authorize your trust settings as the user, you're able to actually add certificates, trusted certificates to a custom keychain, okay? Now the trick is, create a new keychain, add your certificate to your new keychain, add your certificate to the system keychain without any trust. That you can still do it. Now just add your trusted certificate to the custom keychain with all the trust settings, everything, right? And then just add that custom keychain to the search list. And now both certificates are now trusted. So now you can just do the same thing again, right? So now you can just set up your proxy, set up your pack settings. Now it doesn't break Firefox again. And now you're set up, you just set your Wi-Fi proxy settings on, right? And then you just set your MITM proxy remotely. So yeah, what else can we do by proxying all machine traffic? So now we have all the machine traffic. We can disable CSP. We can disable integrity. We can inject JavaScript into the browser of someone, right? So now you just control the whole machine traffic. Is there any tools that you can actually build for this? And yes, there is. So I just created this interesting tool here called Blender. So this tool just has another tool inside, which is Cookie Feeder. So one challenge that we had during the operations was like, okay, so we're grabbing cookies, right? But there's a big problem, right? We want to actually emulate the user browser live, right? We don't want to actually, copy the cookie and then just, add this cookie there one by one, right? So this extension just actually allows you to set up a remote server where these cookies are actually parsed, right, by a MITM proxy script. And then you can actually just point your extension. This is a browser extension. This is a Chrome browser extension. You just point this one to your remote server, click go, and then all your cookies are actually the ones that you capture are just imported to your Chrome profile. So now you just capture your cookies, click go, and now you can actually emulate someone else's browser directly to your Mac, right? Or Windows, it doesn't matter. So now you can just capture everything. Now you got browser dominance. So you can actually just disable CSP, add scripts, whitelist domains, add unsafe online to everything else in the browser of the target, right? So you can now actually control everything. So what else can you do? Why not create a Mythic agent? So sometimes we would get like the Okta authentication, right? So if you guys have ever dealt with Okta, you would see that Okta has a lot of applications. So the user would actually open Okta and have many applications just listed in there. But we wanted to actually not only proxy Okta, we wanted to interact with it. We wanted to launch applications to maybe grab cookies or even, control the applications inside. So what we did is, let's create a Mythic agent. So I just created this one, which kind of like reminds me of Beef. I don't know if you guys ever tried Beef, but this one is kind of like a Mythic agent that emulates Beef, just a tiny bit of Beef, but it has two main functionalities. It has this inline JS persistent and this inline JS function. So how does it work, right? So if you want to actually single execute a command, right, you just use the inline JS. But if you want to execute something that just keeps doing that every time that it gets a check-in, you can just use the inline persistence JS. But how does it work, right? So imagine that this script is launching every time that the user opens a new tab. How does it work, right? So if the user opens like one Google tab and another one, do you get like a new agent every time? And not actually. So the trick for this is that you store all the agent configurations, you store the key, you store the last check-in information in everything, the cryptography key for Mythic communication, you store everything in the local storage. So every time that the script launches in a new tab, you just check the local storage, grab all the configurations, so you have only one single instance of this one running for each tab that you have, right? So now you got like browser dominance, right? So we have browser dominance, we got all the cookies from the user. We have a pretty slick macro sandbox bypass that also gets you persistence. What else can you do? Can we get a TCC bypass maybe? Using this thing here with proxies? And yes, right? So if you guys have ever looked at JAMF, JAMF has a lot of commands that can actually run, right? So it has the JAMF configuration for stall profiles, remove itself. There's a lot of things. If you guys have JAMF right now, just run the sudo JAMF help. You're going to see all of that right there. So there's a lot of things that you can do with JAMF. So I just tried each one of those commands to see what actually I get from the proxy. And I noticed this very interesting one, the pseudo JAMF recon. So this pseudo JAMF recon, what it does is it just pulls from this JAMF server all the extended attributes, the extension attributes that you have set up in your server, in your JAMF server. So what are these JAMF extension attributes? These are essentially scripts that help administrators to, capture information about your machine. These scripts just help you to collect like information about your battery, the install profiles, your brew version, your Python version, the softwares that you have in your machine, right? So you have all of these things in there. You can actually just run the JAMF recon, grab all this information, and now your administrator knows what is installed, right? So that's pretty good, right? But just imagine that when the administrator is running this command, or when you reboot this command, the user would get a lot of TCC prompts every time, or like when he runs the first time. So for example, if the administrator is just trying to read your documents folder or like the desktop to see what is in there, the user just gonna get the TCC prompt. That might look weird. So the user might be like, wow, I don't know what's going on. You get a ping on Slack, it just action like you just file like a suspicious report or something, and that just adds like a lot of confusion. So what JAMF recommends, and probably if you have a JAMF installation, this is probably deployed in your JAMF. JAMF just recommends you to use a configuration called PPC. PPPC. So this is a privacy preferences policy control. It is essentially a profile to allow JAMF to have FDA, the JAMF binary to have FDA. So yeah, you guys can see what I'm actually going, right? So the thing is, well, you just allow JAMF to have FDA, full disk access to your Mac profile, to actually Mac. So now, whenever you run the JAMF binary, this JAMF is not going to prompt any TCC for the user. Your extension attributes are not going to have like a suspicious report just filled out. So everything's good, right? Well, not actually. Since we control the traffic, we can just inspect the traffic that comes from the pseudo JAMF recon, and then just replace that traffic live. So now you can just replace a specific string of this extension attributes, and now we can just inject our own command and then just get the TCC bypass, or actually just launch our command with FDA privileges. And that's the reason for this is because when JAMF recon runs, it's just going to write the scripts to this specific location here, the library application support JAMF temp folder. So every extension attribute that's going to be run is going to be saved in this specific location, right? So what you do is you just inspect that, replace with your command, this writes the script to that location, bash is going to be launched, bash is going to inherit FDA to run all of this, and now your script is going to have FDA as well. So let's see how it works. So this is our script. This is the MITM proxy script that just inspects the specific string. So you can see here that I'm just replacing the user being stat, but this is probably going to work with your JAMF installation. So there's a lot of extension attributes that are just imported by default on your JAMF installation. So this one is probably on your JAMF installation as well. But if you're in an op, you can just check that by yourself. Just run sudo JAMF command, see the traffic, just place your string that you want to replace, and then just run that again. So let's see how it works here. So now we just see the MITM script. We just launch MITM. And now we see that there is nothing. The file is not written yet in the documents folder. And now we just run the sudo JAMF command. Now if found the injection point, you just replace that. And now you can see that your file is just written to that location. So right now we have FDA of your new binary. So now we have reached the end of our journey, right? So just to recap, we got full sandbox bypass with one click for the user. It's pretty slick, right? So the user just doesn't notice anything wrong. We got a proxy technique that doesn't prompt anything to the user. We got browser dominance. We got cookies. And at the end, we got a full TCC bypass. So the idea for this one is that you guys can actually apply all of these techniques into a single campaign. You guys can actually deploy the document and then just reach to the TCC bypass to have full control of your machine, right? So that's all, guys. Thank you. So all of the scripts are here. So if you guys want to take a picture or anything, I'm just going to actually make that all public right now. So just wait 5 minutes. So that's all going to be public. If you guys want to ping me, if you guys want to play some MTG, just send me a ping on Twitter or LinkedIn. So that's all. Any questions? Sure. So what happens is that you have a full article in this Beyond All Launch Agents article there. So what happens is whenever you launch terminal, you can just go to the Profiles tab. And then in that Profiles tab, you can just actually enter a command, a bash single line, right? A bash one-liner there. Just close your terminal. And then after that, it's going to be written to that library preferences com something terminal.plist. So you just add your single one-liner terminal in there. Just close your terminal, save that file, right? And now you can just replace your terminal plist in another machine with this profile, right? So that's the trick. Is that clear?
Okay, so you basically are using that profile file that you created on your system.
On your system.
Transferring it over, and then you're using the Propal installation through Open to make that work.
Exactly. So you create that profile, you create that plist in your machine. You replace the profile preferences with your command, create that on your machine, and then just move that to the target machine. And the way to move it, well, at least in the repository that I'm just doing, is I'm downloading this plist from a remote location, and then I'm just replacing the current plist in the target system with my plist that has the command in there. So that's the trick.
Gotcha.
Yeah. Any other questions? No, it doesn't require terminal to be open. So the trick is when you call open command within the macro, what you can do, and it's not limited within Sandbox, you can just specify the -n, which is going to spawn terminal even if it's already there, right? So that's the trick. So yeah. Any other questions? I don't know. That's a very good question. I don't know. For 1 second, my conspiracy side just got like, well, they might know about this technique or something, but I don't know actually, right? So what's probably happened is that the system is just checking for this specific certificate and is not checking whether the location it is at, right? So it just checks if the certificate is installed. And at the moment, they just grant the trust settings to this certificate whenever it is, right? It just inherits the system. But I don't know specifically how that's doing. I didn't investigate that. I just found that like 1.5 week ago. So when I was doing the presentation. So yeah, I don't know exactly why that's actually working, but right now, Apple developers can actually have a way to deploy certificates to their system pretty easily. Well, until Apple fixes it, but yeah. Or not. I don't know what's gonna happen, right? So I don't know. Maybe OS X 16. I don't know. Let's see. All right, guys. Thank you.